Hello, viewers all over the world. This is your humble mathematician, God we honor. We are considering episode 6, and the question says, find the quadratic equation whose roots are 2 over 3 and minus 9. The question of episode 6 says, find the quadratic equation whose roots are 2 over 3 and minus 9. We start by writing analysis and solution. Okay, as usual, this question is from quadratic equation, and I have defined a quadratic equation in one of my episodes. So here we are expected to generate a quadratic equation now that the roots are given. That is the answers to quadratic problem, which I told us that is called roots. And you can see that 2 over 3 and minus 9 are the roots. So when roots are given, then there's need for you to use it to generate required quadratic equation, and that is what we are about to do. So we can use at least 2 or 3 different methods to resolve this. But because of limited time, let me just use one of the simplest methods to resolve this kind of problem. That is using these two roots to generate an equation. Okay, so all you need to do is just say, I want to use, you can choose any variable of your choice, but I want to use x. I would say let okay, I choose x. You can choose y, you can choose any variable of your choice, but x is what I choose. All I just said is s equals to 2 over 3, or s equals to minus 9. I did not change anything. Just s equals to this, or s equals to this. So the next thing that you do, which implies, yes, okay, this is equals to 0. Okay, so all you do here is yes, transfer just 2 over 3 to left hand side. Yes, the side of x, and you equate it to 0, or from here also transfer this negative 9 to the left hand side. Here on the right hand side is preceded by negative. When it crosses this equality sign, it will change to positive, and that is what we have just done. So at this stage, you discover that a s minus 2 raised to 3 equals 0, or s plus 9 equals to 0. So let's treat this side first. As it stands here, use a 3 to multiply through. So what I mean is this. You can now say, which implies 3s minus 3 minus 7 over 2 equals to 1, 3, 0. So which implies 3s minus 2 1, 0. Okay, so from here, see what I did. I just used 3 to multiply through on this side. So 3 times s will give you 3s minus, 3. This is 3. I'm using 3. That's 3, 3 times 2 over 3. It will cancel themselves to be left with what? 2 equals to 3 times 0 less. Or you still write this. That is just it. Then now that 3s minus 2 equals to 0, or s plus 9, or s plus 9 equals 0. So this s plus 9 equals 0. So you cannot bring them together, which implies 3s 2. Okay, now I have just 3s minus 2 equals to 0, or s plus 9 equals to 0. So I bring them together. So at this stage, whereby I have written them, together, this is called what? Factorization. This is factorization here. But there's need for us to what? To expand it to get the required what? Equation. So we can choose any of the what bracket as our common factor. Okay, let me just choose this. Now the first bracket has my common factor. How did I choose it? I will write it in twos. Then this is what I mean, which implies minus 2. I'll give space 3x minus 2 equals 0. Okay, so from here, write x, this x here, plus then 9 here. Okay, so at this stage, you can now what? Open the brackets. You open the brackets. S times 3s will give you 3s squared minus s times minus 2 will give you minus 2s plus, which is this, plus 9 times what? 3s will give us what? That plus 27s minus plus 9 times minus will give us what? Minus 18 equals 0. Okay? Which implies 3s squared minus 2s plus what? 27s will give us our plus 27s. Yes, because this is, you discover that we have a what? Minus 2s plus 27s. At times, students do make mistake here. So any value that is preceded by what? Positive is greater than any value that is preceded by what? Negative. You can equally write, say, 27s minus 2s to give you this, so that you will not be confused. This is 18 equals to 0. I think this is the required what? Quadratic equation. This is the quadratic equation through which the roots are given. I think that is up to this. Thank you.